Hello guys, good evening. In the previous video, I have discussed a problem called container with most water with the brute force approach where we found out this solution. We were finding out the area in each case, comparing it with the previous maximum and then storing if it was if we would have got a better area, then we would have stored that in the max area variable. And finally, consequently, we will be reaching the maximum area of the container. But the problem that we encountered in that solution is this time limit exceeded error for this vast array, right? Right? But we shouldn't get these kind of problems. We, we are writing, we should write such an algorithm that should pass out in that specific time that is allotted for this particular program. Okay, right. So, in this lecture, we shall discuss the most optimized approach of this solution. Okay, that can give a better time complexity. This code had a time complexity of p go of n square in the worst case. Now, what are the better time complexities we have? We have big O of n. Now we have big O of log n, right? And so on up to big O of 1 is the best, that is constant. Now we can't go with big O of 1 because why? Because we can't go because we do not have any such type of theorem that can do this all these tasks at one step, because we always need to compare something or the other in this array in the given problem in order to reach the maximum area. And to do such comparisons, we definitely need some steps. So, one big O of 1 is not possible. Second is big O of log n. If I go with that, then that is also not possible, because here actually what we have to do is we need to cover all these slabs, right? Because you do not know which where the water fits best, right? It should fit between two such slabs where the area is maximum. Now, we go of log n usually happens where we proceed with a continuous division or a continuous multiplication, right? Continuous division in this case is all not possible, because we can't divide this array and compare, because the portion from where we will be dividing the array and that two slabs may have the maximum area, and in some cases, right? So that big O of log n is not possible. Big O of n, yeah, that can be a possibility that we can have. So as because this was big O of n square, we can do a feasible solution with big O of n time complexity, right? If we go by the constraints, then the length is up to 10 to the power 5. And yeah, 1 lakh iterations at a time, a loop can definitely do, right? It was, don't get confused. It was big O of n square earlier. So we were doing 10 to the power 5 into 10 to the power 5, in the worst case 10 to the power 10 iterations in an approximate way, right? Why at an approximate way? Because if you look at this loop at each specific, when the I increases, j will start from there after that, right? So it is not exactly big O of n square. I mean, not exactly height size into height size. But in the worst case, we always consider the bigger one, right? So it is approximately 10 to the power 5 into 10 to the power 5. Fine. So, and that becomes tedious. But we can consider a solution with big O of n. Fine. How can we do that? Let us see. Now, students, if we talk about area of some quadrant, right? If we consider the area of some quadrant, okay, then be it rectangle or be it square, we can consider rectangle because square is actually a sub, I mean, what to say, a rectangle will only with two same sides. Fine. So better to consider a rectangle. It is basically length into breadth, right? And in this way, in this example, we can, if this is height and this is the length, so length into height. Fine. Now, so if the length is L and breadth is B, in such case, the area can be considered as L into B. Okay, but so if we talk about the area in a specific way, it depends upon both the length and the breadth. S- So what is an ideal maximum area? As we are finding the maximum area in this case, we are trying to find the maximum area in this case. It is a rectangle, or better to say, yeah, definitely we can consider rectangle. The maximum and ideal rectangle with maximum area is the maximum length, right, into maximum breadth. Fine. Maximum height, we can say. Here I am writing. Please don't get confused because we can't have space. Max height, we don't have enough space to, because here we will be running the code of the solution we will be thinking, right? So is max height into max length. So if we consider this rectangle, this has the maximum area, ideal in ideal case. Now, students, this is not possible every time. In reality, either of the one is to be decreased at times when required, right? So we can do either of the one. In this example, in this problem, better to say, a student, we cannot compare bases, right? Because base is one, this whole thing is a base, and this whole these are the heights. Heights we can compare, but bases we cannot compare. Our see, our target is always to get the ideal, but we do not get the ideal. Never, ever, right? Our target is to get the ideal, but we never get the ideal things in life. Similarly, here, in case of area, if we talk about, we will be trying to get the ideal area, that is the maximum area, and in doing so, as we can't compare the bases, we will be taking two pointers in such a way that we take the maximum highest base possible initially. So we are taking two pointers. First one is pointing at the first index, that is 0th index, and the second pointer will be pointing at the last index initially. Fine. In this case now, we as we are comparing with as we are having the maximum base, because from the 0th index to the last index, of course this is the highest base possible base we are having. Now we can freely compare the height, right? Among the heights also we will be trying to reach to the maximum height, but of course as this is the water, as we are having a problem with the water to be filled in the container, while calculating the area we will be considering the minimum among the two heights so that the water doesn't overflow, but our tendency will be to find out the maximum height, to reach the maximum height in order to go to the maximum area. Okay, so our approach will be to find the maximum height at each cases, and we will be calculating, consequently we will be calculating area each time, and we will be comparing with the max area previous maximum. Then of course the same approach as previous in case of area, but this time with only one loop. Okay, so now let us take a variable same as previous, like max area is equal to 0 initially, and area will be same as uh, j minus I into minimum of height of I, comma height of j. Fine. Now, so area is equal to that. Now, so initially when I is equal to 0, I is equal to 0 and j is equal to 8. So area is 8 minus 0 into, now tell me the minimum among these two is 0 and 8. And the height, this has a height of 7 and this has a height of 1. So you'll be considering 1. So 8 into 1 is again 8, right? So so max area is equal to 8 in the first step. Okay. And now after as area is equal to 8, so it is greater than the previous max area, so max area is equal to 8. And now among these two pointers, which pointer is having the minimum height? I, index I, right? So what will it try to do? As I is pointing at a minimum index, I will try to approach the bigger index, right? I mean, not index. As I is pointing to a minimum height, so I will be trying to point to a height greater than that height, right? So in order to do that, I will try to move forward, right? So I turns to be 1. Now, students, in this case, it is happening that I is getting a maximum, I mean, a height greater than his height. It may not happen every time that you always reach a height greater than this, but of course, when you are having a height lesser compared to the other pointer, in that case, you will be if I is having a minimum height, then I will be moving forward to find a greater height, and if j is having a minimum height, j will be moving backward to find a greater height. right? In some cases, it may not find a better height, but it will try to find by moving forward one step only. Okay, so this is the optimized algorithm. This is all about this algorithm. So let us do the other process. So when I turns out to be 1 and when remaining as to be 8, then area is j minus I, that is save 8 minus 1 into minimum of these two, that is 8 and 7. 7 is the minimum, therefore 7 into 7, 49. So is 49 greater than 8? Yes. So max area scores 49. Fine. Okay. Now again, among these, which pointer is having the minimum height? J is having the minimum height, right? So when J is comparing itself with I, it is finding that I am minimum, I am lesser than I. So J will be trying to move backward in order to find a better height that is greater than my previous. Okay, so J is equal to 7. J moves one step back. Although this doesn't find a better height, but it has moved one step backward. Okay, in trying to find. So, but it may not reach a better height every time, like in this case. But we will be calculating the area in all the cases. It is like you can consider an example grades are when you compare your grades with other classmates or your marks, and you find that you are scoring lesser than someone else, then of course with a competitive approach you try to go do better next time. And it may so happen that the next time you may score lesser than what you scored now, but you uh, as a student, we should never lose hope, right? So in this way also we can consider these pointers also never lose hope. When one of the pointer finds that it is lesser, it is having a lesser height in comparison to the other, then it will try to get better, moving one step forward. Okay, and even if it doesn't find, it will be calculating its area and try to improve itself next time. Okay, in this case, so again we find the area when I is equal to 1 and j is equal to 7. So area is 6 minus 1 into 6 minus 1 into the minimum of these two is this is having a height of 3. So 5 into 3, that is 15, and it is not greater than the previous maximum area, therefore max area stays 49. Fine. Similarly, J, again among these, who is lesser? J is having a lesser height, so J tries to find a better height by moving one step backward. So J is equal to 6. Now, among these two, among these two, when I is equal to 1 and J is equal to 6, area is equal to 6 minus 1. In the previous case, it was 7 minus 1. 6 into 3, that should have been 18, right? 6 minus 1 So you can consider this to 8, it is actually 18, but whatever, it will be always less than 49. Okay, so 6 minus 1 into 6 minus 1 into uh, the minimum among these two is none of them are minimum, right? So both are having the same height, so we can consider any one of the heights, right? So therefore 8 is, of course, it's 8, and we get 40. Okay, and max area, it is less than the max area, present max area, therefore it's 49 only, it stays as 49. Okay, now among these two, as no one is lesser, you can consider moving any one of the pointer. Okay, so I am moving I only. Okay, the first pointer. By convention, we can move the first pointer with because it is our tendency to always move the first pointer forward in the forward direction. We don't consider every time moving backward. So actually, you can consider moving any one of the pointers. Okay, in this case, I move I to the next index. So I is equal to 2 and j remains 6. Fine. So I is equal to 2, I equals to 2, and now area is equal to 6 minus 2 into minimum of these two is 6, right? So 6 minus 2, 4 into, because this is the height we are having and this is the height we are having. So 6, I mean 4 into 6 is 24. Is 24 greater than max area? No, not yet. So max area stays 49. Similarly, again we consider who is lesser among these two. Of course, the height at I. So again, I will try to get a better height. And in order to, in doing that, I moves one step forward. I is equal to 3. And again, we calculate the area when I is equal to 3 and j is equal to 6. Area is equal to 6 minus 3 into the minimum is 2, right? In this case, so 2, that is 3 into 2 is 6, and max area and 49. Fine. Similarly, again the lesser among these two is I only. So I tries to move forward. I is equal to 4. Then we are having an index value. So area again turns out to be at I is equal to 4, and continuing here at I is equal to 4 and j is equal to 6, area equals to 6 minus 4 into height is 5, 6 minus 4 into 2, I mean into 5, that is equal to 10, right? So height is 5 here in this case, yeah. And max area stays as it is 49 because it is the maximum till now. Again, we go for I is equal to 5. I is equal to 5. And in this case, we have what? Area is equal to I is equal to 5 and j is equal to 6. Area is equal to 6 minus 5 into what we can say is minimum among these two is having a height of 4, right? So I is having a height of 4, 4, that is 4, And max area definitely again stays 49. 49. Finally, I turns out to be 6. It comes to the same index as j. I is equal to 6. I is equal to 6. And j also is equal to 6. And we have area is equal to 6 minus 6 into whatever be the height. In this case, h. It is 0. Okay. And so max area again stays to be 49. Max area is equal to 49, right? And finally, again, we can consider I turns out to be 7 now. Now. When I is equal to 7 and j is equal to 6, what we are actually doing? Area is j minus I multiplied by the area. So if we do j minus I in this case, so 6 minus 7 is negative. Some negative value into something that gives a negative value. Some negative into obviously height is always positive, and then we get a negative value, and but area cannot be negative, right? Therefore, we stop here. When I crosses j, if I crosses j at any point, we stop then and there. And we return the max area. So what is present in our max area now? So max area is containing 49. So 49 is our answer in this case. Max area is equal to 49 is the final answer. Fine. So let us try to code it down. So what we will be considering? Two pointers again, I and j, int I and j. Till what time we will be running this? We will be having a single loop, and till when will it run? Till I is less than or equal to j. After this we stop because j, I cannot cross j, right? So we can run a loop, that is while I less than equal to j, we consider keeping a max area that is initially 0, right? And what we do here is we take a variable called area, and area is equal to j minus I into minimum of height of I, comma height of j, right? And what will be max area? So if in case of max area, we can say max area will be maximum of the present max area. Whatever we are doing, you can write this using if else also, but using functions looks good, right? So maximum of max area, present max area, and the area that we are getting in this area variable, right? So we need to write these two functions, that is the minimum and the maximum. So if we write int min, we'll be considering two parameters, say num1 comma num2. It will be returning if num1 less than num2. It should return num1, return num1, otherwise return num2, right? Similarly, we can write function for finding the maximum. it should take two parameters, say n1 comma n2, and if n1 is less than n2, and we are finding out the maximum, so as n2 is greater than n1, we can return n2, otherwise we return n1. Fine. Now, so here consequently we will be getting the maximum area through this loop, and so we return the max area. Okay, so just let us let us check the output of this code if we are getting our desired output or not. Mm, yeah, here you have a syntax error, and what else we are having? Any other errors we are having? No. Let me run again. The example again. Time. Wait, just a second. Int I is equal to, oh, I have not given any values, so int I is equal to 0, and j should initially point at the last index, so that is height size minus 1. So hope it should give the correct output. Now let us see. Just to see. So what are we missing here that is giving a time limit exceeded? See students, this time limit exceeded is because of the reason we are somehow getting an infinite loop. Okay, so what is missing here? So this is the while loop starting here. Then we are having the area, max area. Okay, so we are missing the updation of the loop. That is how were we comparing? So we were comparing how the minimum, the pointer that will be having the minimum height will be trying to move forward, right? So we can consider if height of I is less than equal to height of j, that should return, I mean that should, then the I should be I plus 1, right? That is I plus plus in C, we can write it as. Otherwise, whatever it happens, it should be j minus minus. What are we doing here actually? That is, we are doing this part, right? When after finding out the area, the pointer having a lesser height tries to find out a better height, right? So that point we are missing in the code. That is why it was giving an infinite loop. Uh, in this situation, I hope everything is correct and it should pass with correct code. Let's say yeah. So this solution is accepted for the example test cases at least. Now let us submit this and see if there be any error. I mean, or any kind of, yeah. So this solution is accepted compared to the brute force solution that we discussed in our previous video. So what is the time complexity of this code? So the time complexity of this code is, it is having only one loop that is going from 0 to 8 at max. If the array size is very big, uh, it can go, and if it don't finds out a better height, say j is at the last index and j is the highest height, having at the pointer j we are having a highest biggest height, then every time pointer I will be moving, or the vice versa, that is pointer I is having the biggest height, then every time j pointer will be moving backward, that is j will be traveling the whole array, or at the first case, or the former case, I will be moving throughout the array. So at the worst case, we can consider the time complexity to be big O of n, which is uh, big O of n, which is far better than the previous time complexity, which was big O of n square, right? It is basically taking n steps to complete this code. So that was all about the solution. So thank you guys for watching. Stay well, stay tuned.